أعزائي الطلبة طلبة الثانوية العامة، السلام عليكم ورحمة الله وبركاته. أهلا بكم في مراجعة جديدة من مراجعات الألجبرا and Solid Geometry. Question 1. In the opposite figure A, B, C, D, A dash, B dash, C dash, D dash is a cube of side length 2 units. Then find A, B dash dot B, D. Find scalar product A B dash dot B D dot B D. يبقى لازم يكون عندنا طبعا A B dash وعندنا B D. احنا كلنا عارفين انه A B dash equals B dash minus A. Also B D equals D minus B. So we have to determine the coordinates of the point A and B dash and B and D. Solution. The point B dash equals 2, 2 and 2 as the side length of the cube is 2 units. So B dash is 2, 2, 2 and A is 2, 0, 0. A of coordinates 2, 0, 0 and D 0, 0, 0. B is of coordinates 2, 2 and 0. Now A B dash equals B dash minus A equals B dash 2, 2, 2 minus A 2, 0 and 0. So 2 minus 2 equals 0, 2 minus 0 equal 2, 2 minus 0 equal 2. Now we have to calculate B D. B D equals D minus B, D minus B, and the coordinates of the point D is 0, 0 and 0. Coordinates of the point B is 2, 2 and 0, 2, 2 and 0. Now AB dash dot BD equals 0, 2, 2, 0, 2, 2 dot negative 2, negative 2 and B. A B dash dot BD equals the coordinates of AB dash dot coordinates of BD. So 0 multiply negative 2 equals 0 plus 2 minus 2 multiply negative 2, negative 4 plus 2 multiply 0 equals 0. So the result equals negative 4 and the answer number 4. It is negative 4. Question number 2. If Z is a complex number of unit modulus, the length of its modulus equals the unity, equal 1, and the argument and its argument equals theta, then the argument of 1 plus z over 1 plus z bar. Z bar is the conjugate of z. Is one of this choice. Again, if z is a complex number of unit modulus, what does that mean? The length of its modulus equal the unity, equal 1. Absolute z equals 1. So we wanted to calculate the argument of 1 plus z over 1 plus z bar. First, we have to simplify this fraction. Okay, and don't forget that the argument of z is theta. The argument of z is theta. Okay, back to solution. Solution. Let z equals a plus bi. Z is a complex number equals a plus bi. Then z bar, its conjugate equals a minus bi. Multiplying up and down by a plus bi over a plus bi. What we get? We get in the numerator a square plus b square over a plus bi. A minus bi multiply a plus bi equals a square minus bi all square, and the I square equals negative 1. So a minus bi multiply a plus bi equals a square plus b square over a plus bi. But a square plus b square is the modulus of z, and the modulus of z equals unity, equal 1. So we can substitute a square plus b square equals 1. Okay, again, a square plus b square equals the absolute of z, which equal 1, and a plus bi equals z. So we proved that z bar equals 1 over z, so I can substitute in the denominator here. Instead of z bar, we can write 1 over z as, okay, 1 plus z over 1 plus z bar equals 1 plus z over 1 plus 1 over z. Now, to simplify this fraction, multiplying up and down by z. Multiplying up and down by z. Z multiply 1 equals z. Z multiply z equals z square. Z multiply 1 equals z. Z multiply 1 over z equals 1. We can take z as a common factor. So we have between brackets z plus 1 over z plus 1. Simplify. So we get z. Z plus 1 over z plus 1 equals 1. Multiply z equals 1. So this fraction, the given fraction, equals z. What is the argument of z? From the given, the argument of z is theta. So the argument of this complex number is theta 2, and the answer is 3. I hope you understood it. Question 3. The amplitude of this complex number, we have here complex number, and the question is about the amplitude of this. Amplitude, it is theta. So first we have to simplify it. Solution. Root 3 plus I all power 4n plus 1 over 1 minus I root 3 all power 4n equals root 3 plus I over 1 minus I root 3 multiply root 3 plus I. Note here that root 3 plus I power 4n plus 1, it is the product of root 3 plus I power 4n multiply root 3 plus I. As you know, when you multiply, we add powers. 4n plus 1, 4n plus 1. Now we want to simplify this fraction, multiplying up and down by I as follows, equals multiplying up and down by I root 3 plus I root 3 plus I over multiplying 1 by I, we get I, multiply negative I root 3 by I, we get negative I square, and I square equals negative 1. So the result will be root 3. Again, to simplify this fraction, we multiply up and down by I. Multiplying the numerator by I, we get I root 3 plus I. Multiplying the denominator by I, we get 1 plus root 3, as I square equals negative 1. Multiply negative, we have positive. And by simplify, we have here I power 4n. And don't forget to write root 3 plus I, root 3 plus I. So the result equals equal I power 4n multiply root 3 plus I. I power 4 equal 1. I power 4 equal 1. Also I power 4n equals 1. So the result equals root 3 plus I. Root 3 plus I. This is the simplest form to this fraction, to the given fraction. And the amplitude equals 10 minus 1, 1 over root 3. 1 over root 3. It's equal pi over 6 or 30 degrees. Okay, first we simplify the fraction. Then we put it in the simplest form. It is the main idea, to put the fraction on the simplest form, root 3 plus I. And from that we can get its angle, theta. Amplitude equals 10 minus 1, 1 over root 3. Equals pi over 6, and it lies on the first quadrant. So we will take the first answer, pi over 6. And the pi over 6 is the amplitude of this complex number. And the answer is 3. Question 4. The coefficient of x power 3 plus, the coefficient of x power 3 in 1 minus x plus x squared power 5 is negative 30, negative 20, negative 10, or 30. So the required is the coefficient of x power 3. So 1 minus x plus x squared all power 5 equals 1 plus x multiply x minus 1. Multiplying again x multiply x squared equals x squared. X multiply negative 1 equals negative x. So again 1 minus x plus x squared all power 5 equals 1 plus x multiply x minus 1 all power 5. And we have to use the expansion of the binomial. Okay, so we have two terms. This is the first term, and x multiply x minus y minus 1 is the second term, and n equal 5. So the expansion is 5c0 plus 5c1 x multiply x minus 1 power 1. Here 1, we have here 1, plus 5c2 x square x minus 1 all square. The second term here is square 2 plus 5c3 x power 3 x minus 1 all power 3. The required is the coefficient of x power 3. So next terms the powers will increase than 3. It will be 4 and 5 and so on. So we stop here. Equals, so the coefficient of x power 3 equals the coefficient in this term plus the coefficient of the fourth term. Here first term there is no x power 3. There is no x power 3. In this term we have x power 3 because x minus 1 power 2 equals x square minus 2x plus 1 minus 2x. Here it is the middle term, of in the expansion of x minus 1 all square negative 2x. Negative 2x multiply x square equals negative 2x power 3 multiply 5c2. So the coefficient will be negative 2 5c2 minus 5c3. After you expand this, we get 1 multiply 5c 3x power 3. So one of the terms of this expansion is 5c3x power 3, and its coefficient is negative 5c3. Negative 5c3, we write it here, and we calculate it. We get negative 20 minus 10, which equal negative 30. Question number 5. If theta is the measure of the angle included between A 202 B 004, then theta equals one of these values. So the required is to calculate the measure of the angle included between these two vectors. Solution: cosine theta, you have to memorize it. Cosine theta equals absolute of A dot B over norm of A dot norm of B, which equal absolute, here we have absolute 202.004 over 2 square plus 0 square plus 2 square multiply square root of 0 square 0 square 0 square again 4 square, which equal 8 over 8 root 2. 8 over 8 root 2. So theta equals cosine minus 1 over root 2, which equal 45. As 8 over 8 root 2 equals 1 over root 2 in the simplest form. So theta equals cosine minus 1 over root 2, which equal 45. So the measure of the angle included between the two vectors is 45. Question number 6. If the point C is the midpoint of AB, where A equals 1, negative 4, and 0, then the point B is, so we have 2 points A and B. We know one of these points, one of them, A equals 1, negative 4, and 0, and B is unknown. We consider it x2, y2, z2, and the middle point is C. C equals 2, 2, and 6. So what's the coordinates of the midpoint? Midpoint of line segment AB. The coordinates is C equals x1 plus x2 over 2 and y1 plus y2 over 2, z1 plus z2 over 2. This is the coordinates of the midpoint in the 3 dimensions. So C equals 2, 2, 6. So 2 equals first coordinate x1 plus x2 over 2, and x1 is 1 from the given, over 1 plus x2 over 2. y1 equals negative 4. We write negative 4 over 2. z1 is 0 plus z2 over 2. And from here, using cross multiplication, we get B equals 2 multiply 2 minus 1. Okay, this is the second point, because second point is x2, y2, z2. So the first coordinate will be x2, which equal 2 multiply 2 minus 1, and y2 here equals 2 minus 2 plus 4, and z2 is 2 multiply 6 minus 0. So the coordinates of the point B is 3 and 8 and 12. 2 multiply 2 minus 1 is 3. 2 multiply 2 plus 4 is 8. 2 multiply 6 minus 0 is 12. Question 7. if the vector A makes angles of measure alpha, beta, and theta with x, y, and z axes, then cosine 2 alpha plus cosine 2 beta plus cosine 2 theta equals one of these values. Cosine 2 alpha plus cosine 2 beta plus cosine 2 theta equals, first, cosine 2 alpha equals 2 cosine square alpha minus 1. Also, cosine 2 beta equals 2 cosine square beta minus 1. Cosine 2 theta equals 2 cosine square theta minus 1. By taking two common factor, we have to multiply cosine square alpha plus cosine square beta plus cosine square theta, and negative 1 plus negative 1 plus negative 1 equals negative 3. But we know that cosine square alpha plus cosine square beta plus cosine square theta equals 1. So the result equal 2 multiply 1 minus 3, which equals negative 1. So the answer number 3, negative 1. Question 8. If L1 straight line x whose equation is x plus 2 over negative 1 equals y plus 3 over 3 equals z plus 5 over 2 is perpendicular to the line L2 whose equation is x over 2 equals y minus 5 over k equals z minus 6 over m, then the value of 3k plus 2m equals one of these values. So we have L1 perpendicular to L2. It means the direction vectors D1 and D2 are also perpendicular. The direction vector D1 for the straight line 1 is perpendicular to the direction vector of L2. It means D1 dot D2 equals 0. Negative 1 multiply 2 plus 3 multiply k plus 2 multiply m equals 0. It is a scalar product. So negative 2 plus 3k plus 2m equals 0. Again, negative 1 multiply 2 equals negative 2 plus 3 multiply k, 3k, 2 multiply m is 2m equals 0. It means 3k plus 2m equals 2, and this is the required. 3k plus 2m equals 2, so the answer is number 2. Question 9. If A equals negative 1, 3, and 4, B is the point 0, negative 2, and 5, then the norm of vector AB equals one of these values. So first we have to calculate AB. AB equals B minus A, which equal 0, negative 2, and 5 minus negative 1, 3, and 4, which equal 0 minus negative 1 is positive 1, negative 2 minus 3, negative 5, 5 minus 4 equals 1. So the norm of AB equal the norm of this vector, which equal square root of 1 square plus negative 5 square plus 1 square, which equal square root of 27, which equal 3 root 3 length unit. Question 10. How many triangles can be formed by joining the vertices of an octagon? First, we draw the octagon, and we have 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8 vertices. The vertices of triangle is 3. So every 3 point 1, 2, and 3, for example, can form a triangle. So we distribute 8 vertices over 3 by combination. So the number of triangles is 8C3, which equal 56. So the answer is 56. Number 4. 11. 1 plus 2 omega power 5 plus 1 over omega square multiply 1 plus 2 omega plus 1 over omega power 4 equals 0, negative 1, 1 or 2. Solution. We have the required here and the properties of omega. We know that omega power 3 equal 1 and 1 plus omega square equals 0. So omega power 5 equals omega power 3 multiply omega square, and omega power 3 equal 1. 1 multiply omega square equals omega square. So we simplify omega power 5 to be omega square. Also omega power 4 equals omega. And if 1 plus omega square equal 0, so we can say that 1 plus omega equals negative omega square. 1 plus omega square equals negative omega. Omega plus omega square equals negative 1. And we'll use these properties to solve this problem. So 1 plus 2 omega power 2 as omega power 5 equals omega power 2. Omega power 5 equals omega power 2. 1 equals omega power 3. Omega power 3 over omega square equals omega. Multiply 1 plus 2 omega and 1 over omega as omega power 4 equals omega, and 1 is omega power 3. Omega power 3 over omega equals omega square. And from this we have 1 plus omega is negative omega square. Negative omega square plus 2 omega square equals omega square. Also 1 plus omega square equals negative omega. Negative omega plus 2 omega equals omega. So omega square multiply omega equals omega power 3, which equal 1. So the result equal 1. The answer is number 3. Question 12. If NCR equals NCR minus 1 and NPR equals NPR plus 1, then the value of N equals, so the required here to calculate the value of N. Solution. Since NCR equals NCR minus 1, then R equals R minus 1 or R plus R minus 1 equal N. Again, if NCR equals NCR minus 1, we have two cases. R equals R minus 1, and this is impossible, or R plus R minus 1, R plus R minus 1 equals N. So we use the second relation. R plus R minus 1 equals N, and R equals N plus 1 over 2. Because R plus R is 2R. 2R minus 1 equal N. So R equals N plus 1 over 2. This is equation 1. From equation 2, we have NPR equals NPR plus 1. And NPR equals factorial R over, factorial N over factorial N minus R equals factorial N over factorial N minus R minus 1. Factorial N over factorial N minus bracket R plus 1. So it will be negative R minus 1. and we can simplify this to get n minus r equals 1. n minus r equals 1, but r equal n plus 1 over 2, so we can substitute from 1 and 2 by the value of r. What we get? We get n minus n plus 1 over 2 equals 1. Simplify it, multiplying both sides by 2, we get 2n minus n minus 1 equals 1 multiplied 2 equals 2. So n minus 1 equals 2 and n equal 3, as 2n minus n equals n minus 1 equals 2, so n equals 2 plus 1 equal 3. Question 13. بنكمل مع بعض النهارده المراجعات اللي احنا بدأناها. Question 13. If the two sphere x minus 3 square plus y square plus z minus 3 square equals 16, and the other sphere is x plus 1 square plus y minus 4 square plus z minus k square equals 25, touch each other. Find the value of k. So we have two spheres touch each other. So we wanted to determine the value of k. Solution. The center of the first sphere is 3, 0, and 3, 0, and 3. Here we have x minus 3, so x coordinate is 3, y minus 0, so y coordinate is 0, z minus 3, so z coordinate to the center of the first sphere is 3. And the radius of the first sphere is square root of 16, which equal 4. So we have C1 and R1. C1 is the center of the first sphere. R1 is the center of is the radius of the first sphere. C2 equals negative 1, 4, and k. Negative 1, 4, and k. Also, R2 equals the square root of 5 of 25, which equal 5. So we draw the two spheres C1 and C2, and the radius of the first one is 4. The length of the radius of the second is 5. Now we have two circles touch each other. So what is the length of the line of centers C1, C2? We can determine the length of C1, C2 by two ways. First, 4 plus 5 equal 9, and using the coordinates of the two centers C1 and C2. Like that, C1, C2 equals the square root. It is the distance, C1, C2, it's the distance between the 2 points, C1 and C2. C1, C2 equals negative 1 minus 3 square. So it is equal negative 4 square, which equal 4 square. 4 minus 0 square, 4 square. K minus 3 square, which equal K minus 3 all square. It is the length of C1 and C2 also. C1, C2 equals 9. 4 plus 5 equal 9. So we can write 4 square plus 4 square, it's 32. Root 32 plus K minus 3 square equals 9. By squaring the two sides, K minus 3 all square plus 32 equals 81. So K minus 3 square equals 49. By taking the square root to the two sides, we get K minus 3 equals 7. It means K equal 10, or K minus 3 equals negative 7. It means K equals negative negative 4. So we have two values of k. It is 10 and negative 4. Prove that a plus x, y, z, x and a plus y, z, x, y, a plus z equals a square multiply a plus x plus y plus z. Okay, we will solve this determinant without expanding it using the properties. So by adding c1 plus c2 plus c3, by adding first column plus second column plus third column, what we get? We get a plus x plus y plus z. Again, we will add the elements of second column plus third column to first column. So by adding these elements, we get a plus x plus y plus z. Here, a plus x plus y plus z. After addition, the first column will be x plus a plus y plus z. It is the same. Also, we have here a plus x plus y plus z. Second column is the same, y, a plus y, y, z, z, a plus z. Now, we notice that a plus x plus y plus z is repeated in all elements of first column, so we can take it as a common factor, which equal a plus x plus y plus z multiply 1, 1, 1. After we take it as a common factor, second and third will be as the same. Okay, using the properties of matrices to get the greatest number of zeros here. So by R2 minus R1, R2 minus R1, by subtracting R1 from R2, we get 0 here, and subtracting the first row from third row, we get 0 and 0 here. Again, by R2 minus R1 and R3 minus R1, what we get? We get 1 y z, and the second row will be 0 a 0. Third row will be will be 0 0 0. Now, what is the value of this? Its value is the product of its main diagonal. 1 multiply a equals x square equals a square multiply a plus x plus y plus z, and this is the required